Hello everyone, this is Dr. Amit Kumar Das, and I'm starting this video lecture series on statistics for machine learning. So I think many of you are quite aware of what statistics is, at least the basics of statistics. And many of you are also aware of what machine learning is, right? But the intent of this particular video lecture series is to kind of find out how the two fields, statistics and machine learning, they converge together, right? At the same time, for the people who have started new in the area of machine learning and not so much conversant with the concepts of statistics, at least the fundamental concepts of statistics. So this video lecture series will give them at least some basic exposure to the statistical concepts and some of the tools and techniques. So that is the basic intent of this particular video lecture series. Now, when we talk about machine learning, as many of you are already aware of it, primarily we kind of talk about the first thing that we talk about is the supervised learning, right? The supervised learning concepts, where we kind of try to predict the values of certain outcomes, right? And the outcome, the nature of that particular variable, either it might be categorical or it might be continuous, right? Based on that, we have classification and regression, the two different types of supervised learning. So likewise, we also work on problems and we use unsupervised learning as a tool to solve the problems. And we similarly have reinforcement learning also. Now the question is, all this is good, but where does statistics come into the picture? So as you all know, let's just first talk about the supervised learning so that the concept, I mean, it's easier to establish, right? So in supervised learning, we all know that there is a set of input data, right? And that set of input data, as we call, is basically reflection of the past experience, right? So whatever past information we have gathered in similar kind of domain, we have that fed into the supervised learning model in the form of an input data set, right? And we call that the training data. Okay, a part of that input data, we call that a training data, which is used to train the model. That means the model becomes more aligned with the particular problem domain in the with the help of the input data, which is the training data. Now, uh, in context of that, so we have a data, the input data in place. Now, where the concept of statistical learning comes into play is basically, or rather the statistics comes into the play is that particular data, there are different aspects related to the data. Like for example, before even we start with the machine learning problem solution or modeling the learning or rather training the learning model, we first need to analyze the data set. We need to explore the data set, right? We need to convert the data into information. And we also need to see certain things like how are the different variables in that data set, which are called the predictor variables, how are they related with each other? So different aspects of it, right? What kind of a distribution does the data possess, right? So all those things we need to analyze, and the basic tool that we can use to analyze them is a tool which is a part of the statistics, right? This part of the statistics is also known as descriptive statistics. So it helps in describing a particular data set, input data set, and make certain notion or build certain ideas about the data set, right? So that is one part of the statistics which is called descriptive statistics, which helps in understanding the data, exploring the data, right? Now there comes the second part. Once we have understood the data, basically what we need to do is from that particular input data set, we need to come up with the inferences, right? Inferences about the outcome of the of a particular input data, right? So how do we do that? Now, if we really want to do it in the most ideal way, we need to have all possible types of input data. What we call in the language of statistics is we need to have all possible variability which is there in the data captured as a part of the input data. Now, that is always not possible. There are different limitations. I'm not going to get into the details of that. Probably we are going to cover that as a part of a future topic. But we have to get a small data portion of the data, which we call the sample, right, in the language of statistics. And using that sample, we need to make inferences about the whole set of data, which is called the population in the statistical paradigm, right? So using the sample data, we have to make inferences about the whole population. This also can be done using the different tools of statistics, and that part of the statistics is known as inferential statistics. So first we understand the data, we make a clear notion of the data using descriptive statistics. Next, we use a portion of the data, we call that a sample to estimate or to infer about the whole population, the properties of the whole population. That's called inferential statistics. So as a part of the video lecture series, we are going to cover in small capsules. We are not going to make it a very elaborate session, but in small capsule, we are going to study different bits and pieces of descriptive statistics as well as inferential statistics and how specific elements of these different elements of the statistics are used in the machine learning paradigm. We are going to talk about that, right? So hopefully you are going to enjoy this video lecture series and you are going to get some good takeaways from this video lecture series. Thank you and stay tuned.